Appendix B.3, Part A, solving equations algebraically and graphically. First example here, anytime you have fractions in a given equation, there's many different ways that we can go about solving this. My suggestion is that you multiply by the least common denominator to clear out the fractions right away. So in this case, I can multiply everything in this equation by 12. When I do that with the first term, we have 12x over 3, which is just 4x. 36x over 4, or you can think of 12 divided by 4 as 3, so I'm really multiplying this top by 3, gives us 9x. On the right side, nothing's going to cancel. 12 times 2 is 24. Simplify and finish solving for the variable. X is 24/13. Remember, we're leaving everything in simplified fractional form. Do not change to decimals unless you are given decimals in the original problem. Letter B. Do the same thing when we have variables down in the denominator. Multiply by the least common denominator. In this case, you need to recognize that this x squared minus 4, remember, is the same as x minus 2 times x plus 2. So when we go to multiply by the least common denominator, that is going to be what our least common denominator is. So I'm going to multiply everything in here by x minus 2 and x plus 2. When I do that to the left side here, the x minus 2's are going to cancel, leaving me with x plus 2. When I do that to our second fraction, the x plus 2's are going to cancel, leaving me with x minus 2. In the third fraction, both the x minus 2 and x plus 2's are going to cancel, so we're just left with minus 6x. Once you've cleared out the fractions, follow order of operations and simplify. We need to distribute, add like terms, get the x's on one side, constants to the other. We get x to be -2. And now the last thing that you need to make sure you check for is remember that when we have variables in the bottom or denominator of our fraction, that there's a possibility of there being extraneous solutions, meaning that the denominator is equal to 0. In this case, if I plug -2 in right here, -2 plus 2 is 0. We know division by 0 is undefined, which means that this -2 is indeed what is called an extraneous root. Since it is an extraneous root, that means that this system, or this equation, I'm sorry, has no solution. So make sure you're taking the time to check for extraneous solutions anytime you have variables down in the denominator. You don't want to do all this work right, say x equals -2, and then lose a point simply because it was a no solution problem. Okay, reviewing what we've already talked about in the earlier appendix sections. X and Y intercepts we can find at any time. Let's do the x-intercept first. X-intercept, we plug in 0 for y. That's going to leave us with 2x equals 5, x equals 5/2. So our x-intercept is the ordered pair 5/2, 0. Y-intercept, do the same thing. Plug in 0 for x. This time we're left with 3y equals 5. Y is 5/3, so our y-intercept is the ordered pair 0, 5/3. Third one, approximate the following solutions using a calculator. So we're going to go to our calculator here. We're going to put this equation in. We want to find the solutions to this equation with the calculator. Now, one thing you need to understand, and this is going to be something that comes up all year long. There's different ways that we can talk about solutions. We can talk about real solutions. We can talk about real zeros, or we can talk about real roots. It doesn't matter. All of those will be used interchangeably. Solutions, zeros, and roots. When we're talking about real solutions, real zeros, and real roots, they all have in common that that's the same thing as talking about the x-intercepts. So x-intercepts correspond, when we look graphically at where it's crossing the x-axis, to the solutions of the equation as well. So we're going to go to our calculator, go to our y equals menu, and we're going to put this equation in just like we see it. 2x raised to the third power minus 3x plus 2. Check out the graph of that. Okay, we can see pretty clearly from our graph. I'm going to change my window here to spread it out a little bit more so we can see it a little bit better. Now from our graph, we can clearly see that there is only one x-intercept, which means that this equation only has one real solution. To identify that solution then on the calculator, you're going to hit second function and your trace key to get into your calculate menu. We want to calculate what? Well, an x-intercept is the same thing we just talked as a 0. So I'm going to select number 2. It's going to give you a set of directions. It says set the left bound. So if you were traveling along this curve, we need to go to the left of where that 0 occurs. Hit enter. Then we need to go to the right of where that 0 occurs. Hit enter. It's always going to ask you, do you want to have a guess at this? No, we don't need a guess. Just tell us what the solution is. Hit enter again. There's our 0, which you remember is the same thing as our x-intercept. So negative 1.476 if we round to 3 decimal places. So going back here, we know the solution is x equals negative 1.476. Now remember, there is a difference though in directions whether they ask you for a solution or whether they ask you for an intercept. If they ask you to find the x-intercept using the calculator, you would have to list this as an ordered pair. But since we're just asked for the solution, we're done. Letter B. Before we go to plug this into their calculator, we need to get everything on one side set equal to 0. So we have x squared minus 5x plus 3 equals 0. And now once again, we can go to the calculator. Y equals, clear that equation out, x squared minus 5x plus 3. Again, look at the graph. Here we can see that we have two solutions because we have two x-intercepts. And remember, intercepts correlate to real solutions. So we need to find both of them. Go into your calculate menu again. Calculate a 0, which is number 2. Set the left bound. So I need to be to the left of where that first 0 occurs. Set your right bound to the right of where that 0 occurs. Hit enter twice. There's our first 0 at 0.697. Do the same thing to find the second one. Calculate 0. Now we need to arrow over to the left of where this 0 occurs, which happens to be below the x-axis here. Hit enter. Go to the right of where that 0 occurs. Hit enter. And there's our approximation from the calculator, 4.303. Record each of those answers. Our two solutions to this equation are 0.697 and 4.303. Find the point of intersection algebraically. Okay, anytime you're asked to solve a system, find a point of intersection. Two different ways we have of saying the same thing. Basically what you are going to do each time, this is when we use either elimination or we use substitution. Once again, I do not care what method you use. I like using elimination myself. I think it's a little bit quicker, so that's the method that I'm going to use here. If you wanted to use substitution, it would only make sense to use substitution here if you're going to solve for y in the second equation. Otherwise, you're going to get a bunch of fractions that you're going to have to work with in substitution, and it makes it more difficult than what it needs to be. In this case, I'm going to use elimination, and I'm going to eliminate x's. If I want to eliminate x's here, we have to get opposite coefficients. So I need to take this top equation and multiply it by -2. I'm going to write that then down here. We get -4x plus 6y equals 4, and now I'm going to add up those two equations. When I add them together, x's are gone or eliminated, which is what we want. We have 5y equals 10, so y is 2. Once we know what y is, we can plug back in anywhere we want to find x. I'm going to plug into this second equation. We get 4x minus 2 when we put 2 in place of y equals 6. We have the ordered pair 2, 2. Last one, example 5. Approximate the point of intersection using a calculator. So now again, we're going to go to our calculator and we're going to plug in both of these equations this time into our calculator. First one, y equals x squared minus 3x minus 4. Put in your second equation. We get y equals x cubed plus 3x squared minus 2x minus 1. Okay, there's our two graphs. I'm going to change my viewing window back to my standard window. So I'm going to go back to -10 and 10 here for both x's and y's. Now from this graph, we can see that there is clearly one point of intersection occurring right up here on the left. We're again going to go into that calculate menu. This time we're not calculating a 0, we are calculating an intersection point. So we are going to select number 5. Again, it's going to ask you a couple of questions. What first curve? So in other words, if you have multiple equations, and in our case we only have 2. So what's the first curve that we want to find the intersection of? And now, if there are multiple intersection points, move the cursor close to where that intersection point occurs before you select your function. In this case, there's the first curve, and it tells you that it's selecting equation y1. Hit enter. It's going to leave the cursor close to that intersection point, ask you what's the second curve you want to find the intersection with. It automatically changed to y2. Hit enter. Again, we do not need to guess. Hit enter again, and there is our point of intersection. We're finding a point of intersection here, so that means that we need to give our solution as an ordered pair. -2.175, comma 7.252.